All right, now we're going to get to some of the problems. The problems here actually don't really correspond so much to what we were doing before, but that's still information I think is important. Okay, so let's get into problem 12. And it says, find, and it has nothing to do with the theory we did. I don't understand, but that's okay. Find the slope-intercept form of the equation of the line through 2, 5 that makes an angle of 135 degrees with the positive x-axis. Okay, so what's going on here? We've got a point, 2, 5. Okay. It makes an angle with the we don't know exactly where it crosses the x-axis, but it crosses the x-axis somewhere. And it makes an angle of 135 degrees. Okay, now 135 degrees is actually pointing into the second quadrant, so I'm going to draw it in that way. So I've got some line like so. Okay. And this angle here is my 135 degrees. Okay. What is the slope? We need to find slope-intercept form. Well, actually, it's not that bad. The slope of this line is just going to be the tangent of the angle, right? Because slope, remember, is change in y divided by change in x, more colloquially known as, that's right, rise over run. Okay, rise is that change in y, run is that change in x. Okay, so what we need to say is we're finding this equation, we're taking y minus 5 equals whatever the tangent of 135 degrees is times x minus 2. Okay, that's y minus y0 equals m x minus x0. Let me write that in orange. Okay, and that's for finding the equation of the line through x0, y0 with slope m. Okay, so in this case, in this problem, which is a standard problem in lots of classes, including college algebra, you know the point and you know the slope. So here we know the point, 2, 5, and the slope is tangent of 135 degrees. 135 degrees, that's the same as 45 in the second quadrant, so that's going to be -1. So let me write y minus 5 equals negative x minus 2. Y minus 5 equals negative x plus 2. Y equals negative x plus 7. And if you think about it, if you look at this picture, it sort of lines up, right? That looks to be like that could be plus 7. Okay. All right. Number 14. Number 14 is more like what I was trying to show you guys earlier. It says graph 1 period of y equals tangent of x plus pi over 4. Okay, so all we're doing is we're really shifting everything to the left by pi over 4. So this is a tangent graph shifted to the left by pi over 4. Okay, so let's go ahead and draw that up. So I'm going to have to shift this to the left, so let's move everything to the left. Let's actually start with just the tangent graph. Okay, so I'm going to do the tangent graph, let's say in orange. And I'll do the shifted tangent graph in blue. Okay, so tangent graph, remember, that has an asymptote at negative pi over 2, right? An asymptote at pi over 2, and zeros at pi over 4 are zeros at 0, and 1 at pi over 4, negative 1 at negative pi over 4. It's on this page or this page, right? So this is our regular tangent graph. Okay, so regular tangent graph looks like so. Boop, boop. Oh, I said I was going to do it in orange. Okay, this is x equals pi over 2. X equals negative pi over 2. Now I'm just going to move everything to the left by pi over 4. So pi over 2 plus pi over 4 or minus pi over 4, that's going to move this way in blue. That point's going to be here. That point's going to be here. This asymptote's going to be at negative 3 pi over 4. Okay. Okay, this asymptote here in blue, let me label it, is at pi over 4. Okay. All right. That's pretty much all I want us to know how to do from 4.5. So I will see you all in the next set of videos.